Okay, so let's do the geometry. The mesh, sorry. So select mesh, and you can select any of this. Okay, so let me drop it here. Boom. And now you import here, double click here, and we enter into mesh mode. Okay, and it will import your geometry. So remember, design model geometry, we didn't put the name it selection, so we need to create it inside the mesh mode. Here we have it, so we're going to see those references when we do the mesh. We're going to see that. Okay, we imported the geometry. Okay, we have it here. So what we need to do, so remember here the lighting, remember to choose here CFD. We want to do CFD, take the default values, and if you press generate, it will use some default values. That might be good, might not be good. So in this case, this is what you have, okay? But we can have much more control over this. So let's do a new mesh, okay? And let's add new methods here. So I will use, for instance, right click, method, I will select everything, apply, and instead of choosing automatic, I will choose tetrahedron. So it will put tetra in my whole domain. So as you press generate, and this is what we have, a mesh done with tetra, okay? And for instance, you want to change, you have global and local parameters. So when you select here mesh, you go into sizing, these are global parameters. So this is the maximum dimension of the cell that you will have it here, max size. So if you want to change that one to 0.5, put it there. And this circle that you see here, the outer one represents that maximum dimension. So if you put 0.1, see that the circle is smaller, okay? This one needs to be changed also 0.1. So see that here's how you get those visual references. Okay, so it's here, sorry, 0.5. Okay, here are some other functions that we're not using, okay? So let me put 0.01 and see that the inner one represents your outer circle. Okay, your tetra dimension. But that is global, okay? Global parameter. Let's do the mesh. So probably this one will take longer because it's smaller cells. So let's see. Okay, so see that a nicer mesh, okay? So remember here, control these parameters. Let me put this one 0.1, probably see that you have. Okay, so I don't want to use this method. I want to use another method. Okay, well, let me show you. For instance, you want to add the boundary layer in this one. You go here, insert, and then you go inflation. So where do you want to add the boundary layer? Here, apply, and then that boundary layer will grow in this phase. So here you can choose the phase, apply, and you use those options. Let's use generate. Let's do the mesh. So now we'll do the tetra, and then we'll grow the mesh at the wall, at the surface. Remember to select the surface from where you want to grow your mesh. Okay. We have a mesh here, so here you have the options, soon to fit, and see that we have our nice boundary layer, so you see that you can change those options there. So let's go here, let me erase this one, okay, because I want to use another option. I can do a sweep, okay, sweep like the one with the extrusion in the geometry. We can mesh a face and then do an extrusion of that one, okay. So the sweep, you go back here. Instead of this one, select sweep, okay? And see that in sweep, you have many options, okay? So let's choose here. I want to have triangular face, okay? And here you see that it can automatically detect the faces, source and target faces. So I want to do it manually, manual source. So select this one. And then the target also, you can do both faces. Okay, so let me do also the target manual. Will be this one. Remember to do this one, the geometry needs to be what is called sweepable. Okay, it needs to be able to do the sweep here. If you cannot do it, it will give you an error. Okay, but this easy geometry sweepable. So what we do now, generate mesh. Probably will give me an error or a very bad mesh. Okay, so see, okay, we have the default suction. So see, it created the triangular here, and it did the sweep here in this direction. So that is control here. Okay, so see that the sweep option, let me go here. Number of divisions, okay, default. So if I put 10 divisions here, so see that now we have large cells, okay? 10 divisions. So create one surface here and then do distribution. So here it's up to you to choose the number of divisions or the dimensions. So you have a few options available. You can play with that. So I will put here, for instance, element size, and I will put here 0.01. Which is about the same size of, I think, of this one. So see that you have that. Okay, so probably let's put 0.5, something larger. Okay. Okay, we have this. If you want to check the number of cells, go here, mesh, statistic, remember, and then here you have the number of cells that you have. Okay. So let me use these values, okay, just to get something fast, okay. So now, for instance, we want more control over this phase. We can add, for instance, insert here, and we can go sizing, select this phase, apply, and you choose element size. So I want to use a smaller element, 0.5, generate, and see that mesh this one, and then it will do distribution, and see that the other side it will do the projection. Okay, so feel free to play with the options here, what you want. Okay, and now, for instance, let's add a boundary layer. So here it's not like previously we did that we select the whole body and then the surface. Here, remember, we're working in this phase, so we need to do that at the phase. So insert inflation. So a scope is a phase here. This one, apply, and the boundary is this edge. Okay, so something important. Why did I use this option manually? Because if you put automatic here, automatic source on target, you cannot do the inflation. So you need to have this. That is why I use it manually. Okay, so try to put it here automatic, and you will see that you won't be able to do this selection. So generate, and it will grow boundary layer there, and do distribution. So let's see how many cells do we have. Okay, we have this many cells, and this is cool. So you have more options. So for instance, you can add, for instance, phase meshing. This will be kind of making an structure block topology there. Let's see what we have. Okay, okay, now in this case we cannot use it because it will disable everything there. So you can add more refinement in the phase. You can add also refinement toward in the edges. So for instance, phase sizing, let's go back to 0.1. And let me add a new sizing in this edge. So select the edge here, okay, not the face. And see that it's showing me this visual reference, and I want to put those in 0.05. Okay. Press. And this is what we have, okay? Beautiful. Okay, so play around with all the options. So let's see that we have here about, okay, this is a good mesh. Let's work with this one. But before moving, we need to create boundary conditions. Remember the name selections. Select this surface. So here you have volume, surface, edge. So we need to do the name selections here. In the surface, select, right click, create name selection. This will be inlet. Do it here. This will be wall. And then do it in the other face. Here. outlet. Voila, we're done. You click here and you have your 3 faces. Okay, a little bit about how to move in 3D. Well, probably you just play with your mouse, but middle button, the wheel, zoom in, zoom out. You press the middle button, you rotate, and then control middle button, you translate. Okay, fix this. So this was the mesh generated using the geometry that we created with the same model. So now let's do the same, but with the geometry we created here in SpaceCoin. So again, look at here, drag and drop. Remember that here we have the name selection already. Remember also, now and then just save the project, double click. See that here you have all your files. So SpaceCoin and Design Modeler. You have the path where you can find them. And let's wait while we open the mesh application. Okay, we have the geometry inside the mesh application. So by the way, I'm using Ansys Measure. In the tutorials that I share with you, I think they use Fluent Measure. Later I'm going to show you how to use Fluent Measure. Fluent Measure is very powerful, but I think this is friendlier to use. It's easier to use and you get good meshes. And something very important also, that with Fluent Measure you cannot do 2D meshes. Instead, in the Ansys Measure you can do 2D meshes. So let's work here. We have the geometry. So see that all dynamic selection that we have all of them already here. So generate. We're going to take the default parameters. We don't like those, so let's do that we did previously. Okay, so insert your method, select this one. So this will be very straightforward. Okay, boom. Then swap here, generate. So it's taking some default options. So let me insert now a sizing. So I won't change the source, just to show you the source target, just to show you the problem with the boundary layer. And select this face here, apply, and put this dimension there. Also, I'm not changing the global parameters because the local parameters, okay, have preference over the global one. Okay, so here we're taking our local parameters. Okay, so we have this one. So also we're not using triangles in the previous one. Okay, so now we want to add the boundary layer. So as you go here, size, you go inflation, you select a face, apply, and see that you cannot select it. Okay, the problem is this one that I mentioned in sweep. You need to go here, and at least you need to make one selection manually. So if you do this one manually, your problem here should be fixed. Sorry, it's the face. Boom. See that now you can select it. Select the edge, which is this one, and let's do some 10 layers, and we go there. So remember, if you are using this method, you need to okay, it's giving me this error. A mesh connect current actions and setting size mesh pre-mesh. Okay. So let me go here 5. Let me redo it. So probably I think I need to select the target face as well. I know it was okay. Okay. Yes, it was. No, it was this one. Okay. So it was too large, that one. So let me choose the transition method, first layer thickness, and let me put this one like this, very thin one. Still is giving me problems, so let me put 2 layers. Okay, so yes, the problem is that one, but also, yeah. So let's change the method that we have here. So instead of using the set method, the quad tree, let's use all tree. Okay, so let me see if this one improve our meshing. Okay, suppress. Surface sizing. Okay, okay. Ah, okay, we have it there. And on suppress here, and let's see what we have now. Okay, we have a problem with the inflation layer. So probably, I think maybe it's also related with this one, that all both faces we need to do the selection. Okay. Okay, so you see that we're making many errors here, but it's good to do this so we can learn better. Okay, we learn from our mistakes. Okay, generating now that one should be okay, I hope. Okay, and now I can go here, insert inflation, apply to this face, boom, 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 boom. Then here, so that this apply, and we go here, cross fingers, and still having this problem. The global, okay, so okay, we go global. Okay, remember always to change the method here. So see CFD, we need to use CFD mesh, and likely that will solve our problem. Okay, see that we have it now. Okay, so it wasn't this slip there. Always remember to choose your physics. Okay, so according to what you are doing, you will have different meshing requirements and default actions. So let's put here, for instance, all quad, generate, and you see with quads and inflation, for instance, I put 10 layers. So probably this one will give me an error as well. I know probably it will be too small here. Let's see. Okay. So let's use this mesh, which is not the nicest one, but it's okay. Then you can swap here. You can also swap here. There you can change the number of divisions. Okay, it's up to you. Divisions and statistics. Okay, this is okay. And we already have the name selection. So let's use close here. And we have the two cases. So remember, every now and then save everything. So our next step is just to set up this simulation using Fluent within the Workbench. Okay, so let's see that. See you later.